is Ashish. In this short video, we'll be covering the binary search algorithm. So binary search is one of the most commonly used techniques to efficiently locate a data item within a data set, and the data set should be sorted. And the key idea behind binary search is that binary search assumes that the data item we are looking for is at the middle of the data set. And for example, if we are looking for a data item and if it is greater than the middle item, then binary search does the next search on the right hand side of the data set, and if it is lesser than the middle item, then the search is done on the left hand side, because the data items are in the sorted order. So consider this data set wherein I have the indices written and the corresponding values, and suppose we are looking for the data item 40. So in this case, in the first iteration, binary search calculates the middle index by summing up the lower index and the higher index and doing an integer division by 2. So that would give us 0 plus 5 by 2, which on integer division would give us 2, and at index 2 the element is 30, and since 40 is greater than the middle element, we need to recurse on the right hand side, and that is because the elements are in the sorted order. So for recursing in the right hand side, the over the next pass, the middle element is calculated by replacing the lower index with mid plus 1, which would be 3, and keeping the higher index as the same. So this would give the index 4, and that at index 4 the element is 50. Now 40 being less than 50, we now have to recurse on the left hand side. So recursing on the left likewise is done by keeping the middle element, the left element same, and the higher index is replaced by mid minus 1, which would be 4 minus 1, and that gives us an index of 3, which turns out to be the element we are looking for. So binary search in this case takes 3 iterations and the search is successful. Now what if the user is asking for an element which is not in the data set? Something like 2 or something like 99 or something like 19. So in that case, how binary search works is, let us consider the example 70. So when the user is looking for 70, the first iteration is the same. So 70 being greater than the middle element, which is 30, the second iteration would be to the right, and the end of second iteration, the iteration continues to be a right iteration because 70 is greater than 50, and we recurse to the right. And the third iteration would be your middle element is calculated as the element 5 plus 5 by 2, which turns out to be 5. Now at 5 we have element 60, and 70 being still greater than 60, we again need to recurse on the right hand side. Now in the fourth iteration, our left index, the lower index is replaced by mid plus 1, which is 5 plus 1 and 6, and the higher index is kept as it is. Now since the lower index is greater than the higher index, the algorithm reaches an invalid state and the search fails. So here the search fails. So lower index becoming higher than the higher index is one way wherein we can detect failure of the algorithm to search. So now let's look at the pseudocode for the algorithm we have discussed. So we have the function here. This is the data set, target element, the lower element, index, and the higher index. Now on the first run, if the lower index becomes greater than the higher index, the first condition itself fails and the algorithm fails to find the element. Else we compute the middle element by calculating the integer division of lower and higher indices, and if the middle element is same as the target, then the search is successful. Else, if the target element lies to the left of the middle element, then we need to recurse on the left. So we return binary search of data, this thing. So left index is kept the same and the higher index is modified. And if the target is greater, then we return the right recursion. So wherein we update the lower index and keep the higher index the same. So this is just a pseudocode for the algo we discussed, and that is binary search for you.